Good evening everyone. In this video we are going to discuss about the fasteners. Fasteners, it comes in the part B. Okay, so in this video we are going to discuss about washer, stud bolt, flanged nut, slotted nut, split nut, slotted nut, uh, wing nut, grub screw, countersunk gate screw, Allen screw. So these are all the things we are going to discuss over in this video. So normally in this all those points they are going to give the diameter. With the help of the diameter, other values they are going to relate with the help of the diameter. So in the previous screw threads they are given the pitch value from the other height and the round off. So all those things we are going to calculate over here. So but here the diameter they are given, from that we are going to find the other values. So washer, already we people know that washer is the going to be seated up the screw and bolt so to the particular component, or machine or somewhere else. Suppose in the this one, it is in the V shape head in the screw, in the head it may be in the V shape. Okay, so that washer also it will be making here as a some conical shape in the top of the washer over there. Okay, how we can calculate the diameter? They given some value means, so the outer diameter we are going to find with help of 2d plus 1.5 mm, and inner diameter is the d plus 1 mm. So the diameter of the shaft and other thing they given. So here the internal diameter, the whole diameter d plus 1 mm. The thickness is the 0.15 into d. So like this way we are going to design the washer. Okay, so if the diameter of the shaft they given, so the whole diameter is the d plus 1 mm, and the thickness of the washer is the 0.15 into d. So the external diameter of the outside diameter of the washer is the 2d plus 1.5 mm. So these are all the formulas we have to remember while constructing the washer. The same like stud bolt and the lock nut assembly. Okay, the diameter they are providing over in our question, so that the lock nut and load nut. So the load nut height is the 0.9d. So this lock nut height is the 0.60. These are all the things we have to remember over there. Okay, so the height from here to here, that is the 2d. So from here to here, this will be the uh, d. So on from here to in the bottom. Okay, so the end, it is from nut from here to here, the distance is 1.5d. So the whole space, okay, up to 1.7d, including the V shape, that is the 1.80. So these are all the formulas we have to remember, and then we have to construct the this stud bolt and lock nut assembly. So this usually you are going to construct in the 2D drawing. Okay, so in the drawing mode we are going to construct about this stud bolt and lock nut assembly. Comes into the flange nut. So here they are given the uh, off sectional view. So this is the 3D view for the flanged net. So the flanged net diameter 44 mm. Okay, so then the width across the corner they are maintaining as the like 40 mm, and the chamfer circle. Okay, so this is the call it as chamfer circle. So this will be the 20 mm. So suppose this diameter they are given. Okay, so the inner, that means where the thread is thread diameter is the 20, the whole diameter is the 18 mm. Internal hole diameter is the 18 mm, thread diameter is 20 mm. So then the same thing, so 9 mm from the hole size, and the thread depth size is the 10 mm. So the diameter is the 40, the uh, diameter across the corner is the 40 mm. So the diameter is the 44 mm, height 30 mm, and that small depth extended from uh, the width across the corner is the 5 mm thickness. So depth of the flange net is the 30 mm. So like this way we are going to calculate the flange net. So this is for especially suppose the diameter they given as a 44 mm. Then comes into the slotted net. So the formula they are provided for the slotted net, like from thickness from year to year is the 0.65d. Whole thickness is the 0.65d, and from the small uh, portion as cutted out, so that is the 0.5d. Okay, so this is a 3D model of slotted nut, but the thing is we are going to create the front and top view over here. So after the diameter they are given over this whole diameter. So from that we are going to find out the outside diameter is the 2.2d over here. So from here to here the outside diameter is 2.2d. So the inner one more diameter is coming, that is the diameter is the 1.75d. Okay, so with the help of this formula we have to uh, find out, and also the cut portion. So here some small cutout is coming now, so that it has to be 0.1d. So with the help of this formula we are going to construct over there. So these are all the values we have to remember over here. So split lock, split pin lock nut assembly. So here also the thickness is 0.90, and from here to 0.3d over here 5d they are provided, means this will be the 2d. And here the spin lock nut assembly, so 0.0d thickness. So like this we have to assemble over here. So this is the 3d view of uh, split pin lock nut assembly. Okay, so this is the depth. At certain length we have to make it, so this will be common. And thickness from here 0.2d. Okay, with the help of this formula this pin lock nut assembly you can construct over here. Then comes into the slotted nut assembly. In the slotted nut assembly, uh, from the distance from mid from here to top it is a 0.3d, bottom also 0.3d, up to the wherever the cutout is coming over here. Okay, so this is the from the net size is the 0.9d. So the shaft size normally 5d they are given. Okay, so here the distance from here to here, that is called as 0.2d. So this is a 3d model of slotted nut assembly. We are going to construct these things. So here also these values you have to remember, calculate it. So suppose if given that diameter is 20 mm, means this is the 0.9 into 20, this is the 0.3 into 20, so here 0.2 into 20. So like this we have to construct. Then comes into the wing net. So normally here it does not require any screwdriver or external devices to rotate, because of these wings. While keeping with your fingers, give the pressure over here, automatically with the help of the finger wings it can be rotate over here. The distance between from here to here the diameter is the 1.6d. The wings round portion is the 0.8d. So the thickness of the wing from year to year is the 1.2d. So the distance between from year to year, that is the diameter of the thread is the 2d. So this is the 1.6d. So original diameter is from year to year the diameter is coming over here. Okay, so the outer portion from here to here the uh, distance is 5d. Okay, and also from seeing the top view the wings thickness is 0.4d. Here the curvature forming, no, so those curvature it is in the 0.4d. Along with the formula we are going to calculate each and every value. So from that we are going to construct this wing net. So height is the 2.5. Then comes into the grub screw. So the pi d, the distance is from this cutout is the 0.15d. The height of the cutout is the 0.3d. So here they are going to maintain the chamfer 0.1d into 45 degree. The length of the screw, mm, they are going to given in the question. So this is the about the grub screw. According to that, we are going to design the grub screw. The countersink sung head screw. So here the angle they are going to maintain between this V shape. So that is a 90 degree. The cutout portion is a 0.25d. So from the outer diameter of the top head, that is the 2d, and this is the pi d. So the thread length they are providing. Then from this head of the screw is the 0.5d, and the cutout portion is the 0.32d. So the thickness of the cutout is the 0.25d. The depth of the cut is the 0.32d. Okay, with the help of these values, we are going to construct the countersunk head screw. Then comes into the Allen screw. So the Allen screw, it will be like some rounded space. So this also in this one. So it will be like a countersunk means, so it will be like a counter bore. Okay, normally the counter bore, the straight edge, the same diameter coming, no, same like, but here the extruded portion is coming over here. So the outer diameter is the 1.6d for the head of the Allen screw. So then inner, wherever the hole is coming, so they are 0.9d. Okay, so here they are going to maintain from head to the screw portion like a 0.044d diameter. They are going to maintain the fillet area. Then thread length they are providing, and length screw they are providing. So the diameter, whatever the diameter is given over here, the same diameter is going to maintain for the height of the screw head in the Allen screw. Okay, so from this whole size they are going to maintain as a 0.60. So with the help of that, they are going to with the help of this formula, we have to remember this value we are going to calculate, and we can draw the Allen screw over here. So in this PPT, whatever values related to D, so that depends upon the whatever countersunk or Allen screw or grub head, all those values, formulas we have to remember. With the help of the D, that value we can calculate. The remaining things we have to design over here and draw in the sketch as well as in the drawing mode of the solid edge software. Okay, so this is about the uh, Allen screw, countersunk head screw, grub screw, wing net, slotted nut, all those flange net, stud nut, washer comes under the fastener. Okay, thank you.